Hi YouTube, Colin, MM0OPX here. Something a little bit different for you again. So I've got a little story for you. So a few weeks ago I was in the garden playing about with this, with my adjustable antenna. So this is just a quarter wave vertical antenna in essence. So I was testing this fixed band add-on that you may have seen me speaking about. So what I did was I thought, okay, I couldn't be bothered setting out all the radials in the garden. So what I did was I laid out 4 radials, each of those were 8 meters long. And I thought, well, the ground detunes the radials, so it should be good enough to at least get me a tune and try it out. But when I had this the vertical element on the adjustable fully extended for 80 meters to where I thought it should be resonant, it wasn't. So I thought, oh, there's something strange. The add-on element, the 40 meter element, it was fine. So anyway, I packed up the antenna, but it left me thinking. I thought something's not right here. So I need to investigate further. So this was the antenna setup here. So on 80 meters, it's linear loaded, but that doesn't matter. Doesn't affect things. So I went on to do a little experiment. So started off, set up in the garden as per usual, and what I did was for my base point, I started off with 4 radials at 4 meters long each. I actually halved all my radials because they're much easier to work with, and that is based on this research here by Rudy Severn's in 6LF. If you've not read this paper, then I urge you to read it. It's a very good, very good paper, and you know, as a layman like me, it basically tells you, you know, where the sort of the break-even point is for a number of ground-mounted radials, but we'll come to that later. So on to this experiment. So I set up for 80 meters only in the garden, and what I did was I connected up 4 radials at 4 meters long each. Wrong way. So this was the sweep at 4 radials at 4 meters long each, and I knew this just wasn't right. But then I only had 16 meters of wire on the ground, so the dip wasn't as pronounced, and I expected this to be around about 3.8, but it was way above that, say 4 megahertz. So what I did was I connected another 4 radials, each 4 meters long each, and that made a pronounced difference. So that brought the resonance down by 100 kilohertz, just by adding those extra radials. That's how it came down, how much it came down. So I continued on doing that. I added 4 radials, checked the sweep, added 4 radials, checked the sweep, and I actually ended up. So this was the final thing. So all these radials. This was all that I had at the time. This was 64 radials at 4 meters long each. So that's what that was. If I could find the sweep, and this was the final sweep. So 3797. So I brought it down over 200 kilohertz by the time I added all the radials. So I took some notes. So this is my notes from the field or in the garden. So this was the resonant frequency going by my rig expert. So this was just looking at the SWR plot. So it started off 4 radials, 16 meters, 4002 kilohertz, and by the time I added 64 radials with a total of 256 meters of radials on the ground, this is what the resonant frequency, or what it was showing on the rig expert. So I've actually graphed that, and this is what I actually came up with. So I've graphed this number of radials, and I'm saying perceived resonant frequency. You could take what you want from this. I'm not an expert, but with doing this now then shows me if I'm testing with a vertical and I don't want to put an absolutely massive radials. It shows me how many radials I need to add before it effectively bottoms out. So what you see on my notes here, which is this is what's been graphed, and you could see we've got this quite pronounced curve until we get to kind of 3.8 megahertz. So this was 24 radials, 96 meters of wire, and 4.8. These last numbers are the equivalents of quarter wave radials, which is the kind of the benchmark or the expected. If you're going to make radials, you make them quarter wavelength of the lowest band. So for 80 meters, this would equal 4.8 quarter wavelengths. So going all the way up here, I went all the way up as far as I could go at the time. So that was 64 radials, 256 meters of wire, and 12.8 quarter wave radials worth of wire on the ground. Once you got to this kind of level, it was kind of hard to measure exactly where the lowest SWR was, but I know that kind of from between 11 and 12 or even 10 quarter wave radials worth of wire on the ground, I know my perceived resonant frequency isn't going to get much lower than that. I do have more radials, and I'm going to get those on the ground. I'm probably going to repeat this experiment. So if we relate that to Rudy Severn's paper, he did a similar thing, but he did it for 40 meters. Which one am I looking for? So here we go. So this figure 6 here, resonant frequency of a vertical antenna resonated at 7.2 megahertz with 64 33-foot radials. So that's quarter wave radials as a function of the number of radials. So you can see he actually started with a ground stake. So that's why you're probably seeing this. I didn't have that, as I said. So this curve is almost similar to mine, but it's inverted, which I can't quite understand. So the more radials that Rudy added, the resonant frequency actually rose. Where if you look on my graph, the more radials that I added, the frequency was lower. So I don't know why that is. I'm not an expert. Was it because he had the ground stake as well? Who knows? But that is strange. But if you look at, he's got another graph here. Sorry. He's got another graph here. Yeah, this one. So figure 3, measured input resistance at resonance as a function of the number of radials. And this is what I think I have here. So the more radials you have, this is resistance is actually getting lower. So it starts off obviously no radials, 70 ohms, and it comes down to just below 40 ohms with more radials, and that looks very similar to what I have here. So yeah, if you want some good reading for ground systems for each of verticals, read this paper. Lots of people have covered this, but it really is some good reading. And if I can find the number of radials, yeah, this one here. So this is signal improvement as we vary the number of radials over different soils. So average ground, this one here, this dotted line here. So if you look at, again, Callum DX Commander has covered this in a couple of his videos. And if you look at the sort of steep rise and what you're actually gaining, so if you look after sort of 16 radials, the gain isn't that much. If you look at 0.6 of a dB to 1 dB, 0.4 of a dB, it's not really very much. So as rule of thumb, I'm going to work with, in my quarter wave antennas, I'm going to work with a minimum of 16 radials. It's kind of as a base, but obviously at the lowest frequency. Now I have bought more radials since, because I'm making a 160 meter add-on for my antenna, and I'm currently at about 12 quarter wavelengths of 160 meters. So I want to get that to 16 quarter wavelengths of 160. But then when I use that on 80, it's going to double. On 40, it'll double again. On 20, it'll double again. So that's what I'm basing it on, because I've got more wire than what's going to give me, a little bit of benefit. So I'm basing it on my lowest frequency. So make of it what you will. I hope you've liked the video. Again, first time I'm using OBS here, so I hope this is working all right and looks okay. If you like my video, please give it a thumbs up and hit the subscribe button. That would be very much appreciated. And until the next video I do, it's goodbye for now.